Welcome to homework.
Okay, we've got a few Fisher projections. CH3. I'm going to put pH here for the phenyl ring. Just to save space. And our other Fisher projection. Oh. And we have basically been asked to draw the mirror images of each of these. Okay, so to draw the mirror image of a Fisher projection, you just swap the left and right and leave the middles the same. Right. So the mirror image of the top one is simply that we would go like that. Okay. And so the mirror image of the lower one is simply swapping the left and right again. So H on the left, OH on the right. And we are asked to describe the relationship between each pair of the four structures, right? Well, definitionally, we know that the mirror image of a of any molecule that has one or more stereocenters is its enantiomer, right? That's almost definitional. So that those are enantiomers, and these are enantiomers, right? Okay. So there's two of the possible pairings. Okay. But what about these two? Are they enantiomers or not? You know, uh, well, they're not mirror images of each other, right? So they can't be enantiomers. They would need to be mirror images to be enantiomers of each other. But they are related through a change in stereochemistry, right? They're not the same molecule, okay? They're not. They don't have different connectivity. The connectivity is the same. All that's different is that they've got different stereochemistry, but they're not mirror images. And this can happen when you've got a molecule that has two or more stereocenters. You can end up with a molecule that is known as a diastereomer. That's something in which the only difference between the molecules is their uh, uh, stereocenters, right? But they're not mirror images of each other. Okay. By that same logic, these are diastereomers. Okay. And that leaves two more comparisons, top left to bottom right and bottom left to top right. Okay. And once again, we can see that, if this has NHCH3 on the left and this one has, or on the right, and this one has it on the left, that's swapped. Those are mirrored, but the alcohols aren't mirrored. The alcohols are the same, right? So to be an enantiomer, it's necessary that we've swapped both stereocenters. So like remember this one up here is RS. Then if it's an enantiomer must be SR, right? And this one on the bottom left was SS. Then its enantiomer must be RR. because we're swapping both stereocenters. So if we're comparing SS to SR, we know they're not enantiomers because they don't have the exact opposite stereochemical designations. So these two must also be diastereomers. Similarly, the top right and the bottom right, top left and the bottom right must be diastereomers. Great.